This is Joseph Monty, Fall 2012 Structural Geology. This is the third part of my video. This will be the cross-section. This will be the longest of all the sections. So let's get started. So we've mapped out our region by various layers, beddings, by age of the rock, Cambrian, Mississippian. But now we want an elevation cross-section. This is where Google Earth is a really powerful tool. So I'm going to turn on the layer real quick. I named elevation. And if you notice, it's just going to look like a yellow box has come around my map. And this yellow box really isn't just a yellow box. If I rotate over here, we can see that I have set elevation. Okay, this is called tinning. This tinning is based on, I think the smallest unit is 50 feet, but it's pretty accurate. How Google Earth does it is through a process called LiDAR, and what it is they have a satellite in orbit and they shoot lasers, millions and millions of lasers in a systematic pattern, and then they take the travel time to determine the elevation based on that. So this is the basic elevation of the region. I shouldn't say basic, it is the elevation of the region interpolated from Google Earth, and that is my Google Earth mesh and surface together. And when you get further along into the AutoCAD program, you can actually make a cross-section line. So I'm going to turn mine on in here, which is orange. You'll see it in a second. There it is. It's hard to see with the surface on, so I'm going to turn off the elevation. This is the change in direction point. So let me turn off my surface elevation so we can see a little better. Cool. Come down over here. So this is the basic elevation of the region, and it's really quite impressive that we can get that accurate of data from the region. So this is not actually my cross-section. I was running out of virtual memory to process some of the things I was going to be doing. So I just copied this and I put it in another file, and I'm going to go to that real quick. It's called cross-section, surprisingly. Not surprising. So this is a basic cross-section of between Blacksburg and Newport, which each of the layers represented. We can see the relative thickness. They're done perpendicular. And the beds are roughly constant thickness. It's a little different at the origin because of different strikes and dips. How I measured was a basic AutoCAD tool. You have a dimension line and you can align it, and then I just snapped it perpendicular to the 2 points, which is pretty cool. I have a total length of a little under 25,000 feet for the area that we mapped, which isn't too bad. I'm not quite sure what the accepted value would be here, but all of my thicknesses are given that can be known. I don't know how thick this moccasin is because I don't know where it ends past here, so it'd be silly for me to put any dimensions. So the Cambrian on this side is roughly 4,000, Ordovician 2,500, Silurian is the smallest at 1,900. Devonian is the largest at close to 5,000 feet thick, Mississippian close to 3,000, and Cambrian, once again, we have no idea. We know this one's pretty large because it's pretty much all of Blacksburg is this one geologic unit. Also on the cross-section here, I have it on my layouts down here. It's a relative location if strike was projected onto the cross-section for all the different stops that we took. The stops are labeled more detailed in my appendix of my report. You can take a look there. So this is my cross-section. Immediately to the right over here, I have my strat column for the region. We have the Cambrian that we have no idea how thick, the Pulaski thrust, which is exaggerated. It's not to scale. It's just so that you can see the purple in there. Mississippian, Devonian, Silurian, and so forth. And then over here, we have to scale to the Silurian that we are doing this column for. So in here I have figures. These correlate to, I want to say, Appendix B. I have pictures of all these different units. You can take a look see what we do, what we did wrong. Not really. And my dimensions are in feet. We're in imperial right now, as opposed to meters, which I didn't want to switch up the units. It doesn't make sense for me. If I'm modeling in feet, I should keep my dimensions in feet. That's what makes the most sense to me. And here's the layout. You have what's called a viewport window, which is, if you think of a picture frame, what's inside the picture frame, and everything on the outside is the wood of the picture frame. So that's why this is orange, and I think another one is green I made. These are black, because this is 3 different viewports. I'll put into one so you can see the stops relative to the location. And it starts from the top, reading right to left, for all the different things, so you can see where the stops are in relation to my cross-section. The layout 3, the Silurian strat column, normal strat column. My layout 1 is just my cross-section. The scale that 24,000 to 1 looks silly in AutoCAD. It's not, you couldn't read much even if I did that, so this is why I put in the scale bar. Hopefully the graders can see everything here. If not, we'll figure something out. I'm not too worried about that. The other thing I did with this model as opposed to the last one I had, I straightened out this strat column line because the cross-section line, because we did bend, we had that angle shift, and we do have to account for that in our model. So that is straight. Everything is labeled, hopefully to your liking, and that's pretty much it. This is pretty much the entirety of the project. It's if I went by step, it'd take me a while, but it's convenient using AutoCAD. It's a powerful tool that I don't think college uses enough to integrate between geology and mining. It's underutilized, and we have the resources here. It's just training. But that's why we have an ArcGIS class. You can do this in ArcGIS. It's a little. I'm not as familiar with the program. You can probably make a nice subsurface map using ArcGIS. I have no idea how to use it. I've only used it a tiny bit. But this is my Blacksburg Newport project. Please feel free to email me if you have any questions regarding this. I'm up at weird hours, so you won't bother me. I'll try to get back to you as quick as possible. And I hope this helps for future engineers or geologists who are trying to make this reality in AutoCAD as opposed to on paper. Thank you so much.